listeners, I am Dr. Anuj Sharma, working in Center for Advanced Studies in Mechatronics program, which is in campus research driven institute of Dr. APJ Abdul Kalam Technical University located in Lucknow. So, we are discussing on the fundamentals of mechanical engineering and mechatronics. So, today's topic is numericals on beams. So, in the previous lectures, we have already discussed about the different types of beams, beam classification, different types of load, different types of supports, and how we can draw the free body diagram of these beams. So, we will quickly will do the recapitulation also for that particular thing, but before that we want to go to the outlines of this particular presentation today's this lecture. So, we will discuss the brief introduction of the beams whatever we have already discussed in very short time, and then we will do the support reaction calculations or for different beams working under the different loading conditions. So, we now we know till this point we know the different types of supports. So, three types of beams we first we have to now we understand statically determinate beams. In which simply supported cantilever and overhang beam. So, these three beams now we know. Types of loading if we talk about. So, we have studied three types of loading: point load, point or concentrated, and second is uniformly distributed load, in short UDL, varying distributed load, in short VDL. So, point load we generally show by this kind of structure, UDL generally will show either by this or by this arrow of same dimensions. VDL means we will go by this, intensity is varying from one end to the another end. So, here you will have the different intensity at one end different, another end different. Different types of supports we have already discussed. Four types of supports. One is the simple support, roller support, hinge or pin, and the fixed support. Simple support we got the reaction because these things are very important to understand when we will draw the free body diagram to solve any beam. Simple support will always get the one reaction. So, reaction is always 1. Roller support again the reaction is perpendicular to the roller surface, always we will get the one reaction. In case of hinge we will have two mutually perpendicular reactions, always we will get two reactions, and in the case of fixed we will have three reactions, two mutually perpendicular and one is movement. So, we will get the three support reactions. So, likewise this is very important to understand to move further to have a discussion on the numericals. So, initially we will take very simple numerical, sometimes the questions can come. Let us say you have one beam, this is simply supported. So, let us say this is the symbol of one support, I do not know whether it is which type of support it is, another support is this, and one point load is given, that is W Newton at the length of L by 2 and L by 2. Let this end is A, this end is B, and this is C. So, this type of beam is given. Now, the question is calculate the support reactions at A and B. So, we have two supports. So, we have to calculate the support reactions at A and B. So, first we have to draw the free body diagram. So, it is always suggested to draw the free body diagram below this, because in this unit after some topics you will have to study the shear force and bending moment diagrams. So, for that we have to draw the free body diagram and we have to calculate the support reactions. So, you can like this, so that we can easily mark the points below the beam. So, draw, first of all we want to draw the free body diagram. So, we are drawing the free body diagram of this beam. So, you draw the beam. So, beam is this, sometimes may be thicker, so that easily to differentiate. Now, we know from the study which we have already done. So, this is the hinge support. If we can take this hinge, or we can take it as simply supported. So, if we take it as hinge support, then easily we can calculate this beam. So, it is the statically determinate beams, because on the other side it is the roller support. So, provide one reaction here. So, let this reaction is R B. So, reaction at point B. You different books have different notation, sometimes they show the reactions by N. So, you can also take that, but it is different notations you can take, and this is the fixed support, sorry, the pin, the simple support, or you can say the hinge support here. So, here we have two support reactions, one is R A 1 or R A vertical, and this reaction is R A horizontal. And first draw the beam. Now, remove the support, apply the support reaction, likewise we can apply. Now, the third is draw the force as it is, where it is shown in the numerical. So, it is W and this length is L by 2, this length is L by 2. So, it is acting in the midway. So, now we have three equations of equilibrium. So, if this beam is in equilibrium, so it must fulfill these three equations of equilibrium. So, first of all, first equation is sigma f x equals to 0. So, it means all the forces in the x direction should be 0. So, fortunately, unfortunately we have only one force here. So, R A H equals to 0. So, this force is equals to 0. So, if you have taken this support as a roller support also, or as a pin joint also, as a pin joint if you will take, you will have to show two reactions, but out of these two reactions one horizontal reaction is 0. So, it means if you would have taken this support as a simply supported support, then the answers which you are getting, that is also correct. Okay. So, you can take this support as a simply support, as well as you can take it as pin support. So, nothing is going to be changed in the numerical. So, and before that you can also take the sign convention. So, we have taken the standard sign convention, this side positive, this side negative, y upward positive, y downward negative. Clockwise movement, anti-clockwise you can take negative, clockwise movement you can take positive. So, this is the standard notation we can also take. So, now sigma f y, second equation. So, if we will take the second equation, so apply on this particular beam. So, here we are having three forces in the vertical y direction, 1, 2 and 3. So, R A V, this is going upward positive, minus W going downward negative, plus R B going upward. So, it should be 0. So, what we are getting from here, R A V plus R B equals to W. So, it will become positive. So, let us say this equation is 1. Now, third equation is sigma m. Now, we will have to define ki about which point you want to take moment about which point. So, we want to take moment about A point. So, sigma m A equals to 0. So, let us say you take about this point. So, it means these two points are, these two forces are passing through this point. The moment of R A V will be 0, R A H is also 0. So, the moment is W will go like this, and the distance is, perpendicular distance is L by 2. So, what would be the moment here? W into L by 2. So, it is clockwise. So, that is why it is positive. Now, this force is R B is acting vertically upward, and if we rotate this force about this point, so it will go like this. So, it will go like this. So, it means it is negative movement. So, the movement is minus R B into total distance is how much from here to here, that is L equals to 0. So, if we will write it as W into L by 2 is equal to R B into L. So, L will be cancel out, or R B will equal to W by 2. and you put this value here. So, this is equation number 3. So, you can put this value here, you will get R A vertical, again it is W by 2. So, likewise you can easily calculate the support reactions, because for drawing the free body diagram we need to replace all the supports, we have to make this body isolated from all the supports, all the contacts, then we can apply these 3 equations of equilibrium and easily we can calculate the support reaction. Now, I will take the second numerical, very simple again. So, I am taking case by case, so that you can easily understand and you can solve the difficult problems. So, let us say in the previous case I can apply this force here, this is force is W again and this angle is theta and this is L by 2, this is point A. Now, the situation is different, means the beam situation is same, but the force orientation or force application is different. So, what we have to do in this case, it is very simple, I am just giving you a hint, you can solve this question, I am not going to solve this question till last. So, I am just giving the hint. So, what you can do, you can resolve in this situation, if you find any inclined force or any inclined plane, you can easily resolve the force into vertical x, vertical y and horizontal x direction. So, here you should do this. So, you can resolve this force into the component. So, it will be W sin theta and this component would be W cos theta. So, in place of one force, now we have 2 forces, this distance again L by 2, this distance again L by 2. Now, this is the vertical reaction R A V. Now, if because I know the horizontal force system should be 0. So, I can use my knowledge and experience and I can apply the support reaction in this direction, that is R A H. In the previous case you might have remembered that we have applied the force in this direction. So, because at that time no force was acting in the horizontal direction, that is why I used some intelligence, but here I can also use that intelligence if one force is acting in this direction. So, the direction of that reaction definitely would not be in this direction, it would be reversed. So, if you will take this precaution, you will get the answer positive, but if mistakenly you have not taken this force in this direction, you have taken in this direction. So, no need to worry, you will not get the wrong answer, in answer you will get the negative sign. So, negative sign means the direction whatever you have taken that was not correct, that may be reverse direction. So, that is not going to affect the end results of the numerical, and again this is the roller support. So, you can apply this reaction. So, now you can easily solve. So, R A H is equal to W cos theta, 1 would be there, and R A V plus R B is equal to W sin theta. So, likewise you can apply the equations of equilibrium and you can easily solve this numerical. So, now further I will take different case. Let us say this is the numerical, this is the beam and we have this joint here. So, which type of joint it is there? At A, which type of joint? It is the hinge joint, pinch joint, and this is the B, it is again the roller support, right. And we have one uniformly distributed load. So, this is W Newton per meter and the length of this beam is L. So, now what you can do? You draw the free body diagram. So, believe me, the methodology which I am using, you should use this, you draw, you keep the portion which is below the beam, keep empty. So, just first draw the free body diagram here. So, draw the free body diagram here, then when we will come to the topic shear force diagram and bending moment diagram, then draw the shear force diagram here and bending moment diagram here. So, no error will be there if you will use this methodology. So, it would be very easy to draw the beams again and again, and you not need to be worried about the locations of different points in the beam. So, draw the free body diagram. So, first draw the beam. Now, remove this load, remove this support. So, this is the pin support. So, you apply the 2 reactions, or you can easily, this is R 1, this is R 2, no need to be put R A 1, R A 2. So, that will create more confusion. So, you can keep it more simpler also. So, R 1 R 2 means these two support reactions, one is vertical, one is horizontal, R 1 R 2, and this is the third reaction R 3. Now, you have to remove this UDL. So, where we can apply? So, the intensity of this UDL will be W into L, and it will act as a midpoint W L at the midpoint means L by 2 L by 2. So, what would be? Now, this is you can apply the equations of equilibrium. So, sigma f x equals to 0. So, what you will get? Sigma f x means R 2 equals to 0, simply in straightforward. No, we do not have any horizontal force except R 2. So, R 2 would definitely be 0. Now, another force is sigma, another equation is sigma f y equals to 0. So, if we will use this, sigma f y means R 1 vertical plus minus W L negative downward plus R 3 equals to 0. So, what equation you will get? R 1 plus R 3 equals to W L. Now, third equation sigma m equals to 0. So, about which point? So, always try to have the moment about that point where you will have maximum number of forces. So, you not need to go for the longer calculation. So, if we are having two forces passing through this, one R 1, one R 2, so you take about moment this point. So, if you will take about this point, the moment of R 1 and R 2 will be 0. So, W L into L by 2. So, it will be clockwise, right. So, no need to do this, I am just doing just to help you, just to make you understand, and minus R 3 into L equals to 0. So, if you will see here, so W L square by 2 is equal to R 3 into L. So, this L will cancel out this square. So, R 3 is equal to W L by 2. Put this value in this expression, you will get R 1 is equal to W L by 2. So, I am going towards the stricter problems. So, I have taken this simple problem. Now, again we will take each and every case, then we will combine all these cases to form a typical complicated problem. Now, let us take one problem. This is little bit complicated. So, this is the problem actually. So, let us say at this point it is 2 Newton per meter. The intensity, this is the varying intensity, na? This is the varying distributed load. Let us say at this point it is the roller support, and another point it is the hinge support. Here the intensity is 2 Newton per meter, here the intensity is 8 Newton per meter, and the total length of this beam is 3 meter. This is point A, this is point B. Determine the support reactions. Right. So, support reactions means at A and at B. So, what we can do? We can draw the free body diagram. So, this is the beam, this is point A, this is point B. Now, at point A we have roller support. So, we will have only one reaction. At point B we have hinge joint R 2, R 3. So, we have two support reactions. Now, this looks like a VDL, but actually it is little bit tricky to convert it into the UDL plus VDL. How? If you have this kind of situation, then what you can do, we can easily divide this into two loading conditions. This is the UDL, if you will see. So, it may be a combination of, here the UDL intensity is how much? We can split it into two parts. One is the UDL up to this, whose intensity is 2 Newton per meter, from this end to this end it is constant. Now, another we have the second part as the VDL. Here you can see the intensity is varying, from at this point it is 0, and at this point the intensity is how much? It is intensity is total 8 minus 2. So, it is 2. So, this intensity would be how much? It would be 6 Newton per meter, keeping the total intensity constant at 8 kilonewton 8 Newton per meter. So, likewise we can divide it into two parts. So, first take this UDL. So, UDL is intensity is 2, length is 3. So, total load would be how much? 2 into 3 is equal to 6 Newton. So, 6 Newton load, the value of this load 2 into 3 is equal to 6 Newton, and value of this triangle is half into what is the base? 3 into what is the height now? This is 6. So, 6 3 is 18 by 2 is 9 Newton. So, it means the total load, total value of this loading is 9 Newton of this triangle plus 6 Newton of this rectangle. So, 9 plus 6, how much it is? 15. So, total value is 15, but we cannot apply the 15 at a particular point. We can apply, but that would be little bit lengthy. So, this is the parallelogram. So, we have to, not parallelogram, means this is the structure where we can easily calculate the area of this. It is a rhombus. So, we can calculate this, but here we should try to convert it into the simpler geometries, like triangle and rectangles are simpler geometries as compared to other geometries. So, that fundamental we have used here. Now, so this is the 6 Newton, it will act 1.5 meter from this point, from this A, and 1.5 of from B definitely. Now, so what we can do now, that triangle is of 9 Newton, where it will work? It will work 1/3 from this point. So, this is 9 Newton, 1/3 of 3 means 1 meter, and 2/3 from this 2 meter. So, likewise you can see we have converted this diagram into simpler geometries of rectangle and one triangle, and we have applied those loads separately at different points. So, let us say this point is C, this point is D, but actually we do not have these 2 points. So, we have drawn the free body diagram of this beam. Now, it is very simple to calculate. Now, you apply the equations of equilibrium. So, sigma f x equals to 0. So, here you will see R3. So, minus R3, no other forces in x direction. So, that is 0. So, it means R3 equals to 0. So, whatever would be the direction of R3, not need to be worried. So, it is always 0. Now, sigma Fy equals to 0. So, sigma Fy means R1 upward minus 6 downward minus 9 downward plus R2 upward equals to 0. So, what is the equation? R1 plus R2 is equal to 15. Let us say this equation is 1. Okay. Now, the third equation, sigma m equals to 0. So, we keep movement about a point A. So, you can see, so this force is also acting, passing through this. So, we can take movement about A. So, now take the moment of R1 moment is 0. Now, another moment is 6 into 1.5. So, 6 into 1.5, it is clockwise positive, plus 9 at a distance of 2 meter, again clockwise. So, 9 multiplied by 2 clockwise. Now, minus R2 into 3. So, this is anti-clockwise, R2 is vertically upward in the right side. So, it is making anti-clockwise movement. So, that should be 0. So, now it is equal to 9 plus 18 is equal to R2 into 3. So, here you will get R2 is equal to 27 by 3 is equal to 9 Newton. right. So, put this value here, R 1 is equal to 15 minus 9 is equal to 6 Newton. So, likewise you can easily calculate the support reactions at different points. So, we will take another complicated problem. You can see how, just first we take very simple problem, then I will let you give one problem a little bit simpler. So, let us say this is the beam, and we have one force here, movement, sorry. So, this is movement, it is L by 2, it is L by 2, no force, no vertical force, only we have this. So, determine the support reaction. So, how to solve this? You can consult any book, or if you do not understand, then I will help you out in understanding this problem. So, just draw the free body diagram. So, let us say this is R 1, this is R 2, because no horizontal force, so no need to mention R 3, otherwise if we will put R 3, that will again 0, right. So, no vertical force, only we have movement at L by 2, L by 2. Now, apply the equations of equilibrium, do not be confused. If we do not have any force, so we have R 1 and R 2 at least, na. So, sigma F y, I am skipping F x because we have not shown the second reaction at A. So, that would be 0. So, sigma F y means R 1 plus R 2 equals to 0. So, from here we will get R 1 is equal to minus R 2. It means, it is very interesting to know that these the numerical value of these reactions would be same, but the direction would be reverse. So, if you will see here, so sigma m, now apply this reaction, sigma m equals to 0 about point A. So, if you will see, so the moment of R 1 about this point is 0, so ignore it. Now, the second moment is m. So, we not need to multiply this moment with this distance, because it is already a movement, m is a movement. So, just add this or subtract it. If it is clockwise, take it as positive, if it would have been negative, so you could have taken it as negative. So, it is on the right side, we have considered the sign convention that clockwise movements are positive. So, this m is positive, and R 2 minus R 2 into L equals to 0. So, this is the reaction. So, it means R 2 is how much? R 2 is equal to m divided by L. So, m is known to us, L is known to us. So, you can easily calculate the R 2, and R 1 would be how much? R 1 would be equal to minus m by L. So, you can put the numerical value, let us say it is 10 Newton meter, it is 10 Newton meter movement, it is R 2. So, you can easily calculate, put this value in this and put the value of L, you will get the reaction. So, likewise we can easily calculate the support reactions, and one question I will give you, you can try at your home. So, this is the beam where this is the UDL, this is the beam. So, just I am putting, I will not going to solve it. This is let us say R 1, this is let us say R 2, this is R 3, and here you can say one movement is also there, right. And if you want to make it overhang, so you can take one force is also there. So, let us say it is 100 Newton making an angle of 30 degree, this length is 2 meter, this length is 4 meter, this length is 6 meter, this intensity is, and this is 3 meter, this intensity is 10 Newton per meter, here intensity is 0 and this intensity is 5 Newton per meter. Determine the support reaction. So, this is the question for you to solve. and this moment is m is equal to 40 Newton meter. Okay. So, I hope you have understood the concept of calculating support reactions. Thank you for watching the video. Thank you so much.